Okay, we're going to start with introductions. Welcome everybody to the first 2021-2022 school year Tech Talk for RMHAM University. Your presenter tonight is Chris Keller. Say hi, Chris.
Hey, everyone.
He did a really nice CHIRP presentation for us last year, and definitely looking forward to this one. I think it helped a lot of folks. We've got a lot of people on here tonight that we did not have the last time, so that's good. We're currently up to 19. One note, in November, on November 13th, we're going to be doing an RMHAM University. This is live in person and also on Zoom. We did one a few weeks ago at our usual spot at Cherry Creek Public Schools. Thanks, Randy Council, for your help on that one. We will be presenting Router OS 101. It's MikroTik Router OS. It's pretty easy to learn if you've got somebody pointing the right direction. We use a lot of that hardware on the RMHAM network, and we're going to pretty much do it like an informal lab. Willem, do you want to have any comments about it?
Basically, what the lab will consist of is we'll have a bunch of these little devices. They're a 3-port router with Wi-Fi, and they do everything that $10,000 version MikroTik device does. It has the same operating system, except that it's not quite as fast and it only has 3 ports. So we'll use this as the actual device that we'll use in the lab. And when you go home, you get to take the device with you, courtesy of RMHAM.
That'll be a good class. If you wanted to know stuff about routers and how to make a MikroTik actually work, which can be extraordinarily challenging, it'll be a good time. And that's on November 13th, Saturday, 8:30 a.m. at the Cherry Creek Public Schools ESC, correct? Is that right, Randy? Educational.
Yeah, it's the ESC building on the southeast corner of East Union and South Yosemite, next to the Cherry Creek Stutler Bowl.
Excellent. If you guys have any questions tonight, remember this is meant to be interactive. Please come online and say something. Chris will be pretty much taking over all of the presentation duties here momentarily. I believe I have it set up so that
recording in progress.
You can present if you want to try just to make sure. There you go. Perfect. Awesome. If you guys do not have that full screen, in the upper right-hand corner of the Zoom meeting, there is going to be some choices in there. You can go to speaker view, gallery view, or full screen. And if you go full screen, generally it will allow you to have the presentation full screen. So make sure you set that the way you want it. Without further ado, we're going to turn it over to Chris and have at it.
Awesome. Thanks so much, John, and thanks, Willem, for having me again and letting me do this talk over. Very excited to be presenting tonight. And as John said, please chime in if you have questions in the midst of this. I'll be taking questions throughout. I do have the slide deck. I've given it to Willem, and probably he's going to have it on the website shortly. And it's a pretty detailed slide deck, so you should be able to follow along with it. So I wouldn't worry too much about taking notes. And of course, we'll have this posted on YouTube later, presumably. But besides that, let's go ahead and dive into it. My name is Chris. I am active with RMHAM as well as with my local ARES team, which is Colorado Region 1, District 6. And I do a lot of software development within amateur radio. That's what I do as my day job. That's how I chose my vanity call sign, SWE for software engineer. And so software is one of the big ways that I can give back to the hobby. So you're all here to learn about CHIRP, but what exactly is it? I've got a quote here from the CHIRP website. CHIRP is a free open source tool for programming your amateur radio. It supports a large number of manufacturers and models and provides a way to interface with multiple data sources and formats. That's kind of a mouthful, so let's dig into what that means. So CHIRP can gather information from multiple sources, can use online repeater websites like RFinder and Repeater Book, and it can pull straight from those if you like. You can import CSV files into it, which we'll explore tonight. And it will export not only CSV files, but also radio image files, which you can upload straight to your radio. And we'll go through a demo of that as well.
Chris, the presentation is now online.
Wonderful. Thank you, John.
It's under RMHAM University course syllabus. It's the first thing in the list.
Perfect. So if you are interested in grabbing that, now would be a good time. There are a couple of things that CHIRP will not do. Right now it is really set up for traditional analog repeaters and simplex channels. It's really not set up for DMR, D-Star, or System Fusion. And, you know, despite the fact that there are dozens of manufacturers and hundreds of radio models, Motorola is one of the big missing names there. And I'm not quite sure if that's because Motorola is too technologically locked down or just because no one has gotten around to it. It could be the former. It could be that Motorola just has such a death grip on things that it's too hard of a nut to crack. But whatever the reason, you've still got to go to Motorola to program their radios. So there's some comparisons here to be made. You could also program your radio from the computer using a program provided by the radio manufacturer. You know, Kenwood releases these things, Yaesu releases these things. You know, pretty much every manufacturer has their own solution for programming their radios. And actually the manufacturer programs are nice in that they are custom built just for that radio. And so they will reach every little nook and cranny, every feature that the radio supports. You can usually find it in these manufacturer programs. The problem with these is that every single radio is a separate program. So if you've got a large, diverse fleet of radios, then this tends to add up very quickly. And they're all different and they don't play together. So you can't build a code plug in one of them and transfer it to the other. In this way, CHIRP is really nice because, you know, it's a single piece of software that you can copy and paste between these radios as you like. The other comparison that I'll make is RT Systems, which is a really fantastic set of software by the company of this name. It's really high quality software. You can copy and paste between radios and the software will figure out what's compatible and what's not. The downside with RT Systems software that I find is that it tends to be a pretty big money sink if you're looking to buy this for each of your radios, because again, each individual radio has a separate RT Systems program. So that adds up in money as well as the number of programs you have installed on the computer. So I'm going to make this analogy. CHIRP is kind of like a multi-tool. It's a single thing that does a lot of jobs pretty well, but it's not the perfect tool for every job. RT systems you might compare to a really nice set of, matched tools. You get really high quality results and you've got the perfect tool for every job, but it's going to cost you an arm and a leg. And then the manufacturer CPS, it's like, one of those dealer-specific automotive tools. It's only really good at getting that last little bit that you can't get any other way, but it's there when you need it. Each of these tools has a place in your arsenal, and so it's good to know how to use all three of these. But for day in, day out, CHIRP is what I prefer to use because it's easy on hand. It works in every operating system. There's a lot of upsides to it. It's just not the perfect tool for every job. All right, so introductions aside, we're going to start talking about what it takes to get information into CHIRP. And let me switch over real quick. Here we have, this is our first introduction to CHIRP here. It's just a blank window right now. And if we open up a new file here, there's still a lot of empty information here. So the question becomes, how do we get the channels that we want into this code plug so that we can then upload it to each of our radios? There's a couple of answers for that. You could of course do manual entry. For each repeater that you want to talk on, type in the frequency, type in the tone frequency. This gets really old after about 10 of them. And, my Aries team has about 200 of these channels that they would like us to have plugged into our radios. I'm not going to sit here and hand transfer 200 channels. I'm just not going to do that. Computers are good at moving information. We just have to teach them how. Second method that I've already mentioned a little bit, these online databases, Radio Reference, Repeater Book, RFinder. These all have a database of repeaters in your local area. You can easily go into them and say, I'm here, I want every repeater in a 30-mile radius, and it will give you a file that you can use. And so that's one way that you can get things into CHIRP, and that's pretty easy. Actually, I didn't rehearse this part, but let me see if I can do that real quick. Query from data source, radio reference, US. I don't have a username and password handy. Proximity query. Let's try this real quick. Did I mention some of this was going to be off the cuff? Distance, 30 miles, band, let's just do 2 meters. See if it comes up with anything. It's got a few of those. So, it's, as you can see, it's pretty easy to get information into these things. I will note that depending on where you live, how diligent people are about keeping these online databases up to date, this may or may not be high quality information. These things are maintained by the community and things get out of date pretty quickly. So, take this with a grain of salt, but at least it's an easy way to get started. But the third way of getting information into CHIRP that I'm about to talk about is doing a CSV import. So you might want to do this if you've got a list that someone else has published, like in my case, my Aries team has published a list of channels that they would like us to have in a certain order. And so, it would be nice if I could put that straight into CHIRP. CHIRP will not import a spreadsheet directly. RT Systems has a wizard that will do it. Maybe CHIRP will someday, but right now we have to do a little bit of what I've heard called spreadsheet gymnastics. We have to, twirl things around until it fits the right shape. And I'll go through a quick demo of that. Any questions at this point? Doesn't sound like it.
Other than your Aries team, are there like well-known sources of CSV files for various organizations?
To my knowledge, I mean, probably many clubs publish these. I imagine, RMHAM has our sample code plugs, and those are especially useful for DMR. I'm not sure if there are any, repositories of these CSV files other than the online databases. Does that answer the question?
Yes, but I mean, every club could potentially make such a file, right? It's just a regular spreadsheet that you can use to maintain it and then just dump it out and post it somewhere, correct?
Yeah, that's very true. And in fact, if clubs are looking to publish that sort of thing, authoring it in CHIRP and exporting from there might be a reasonable way to go. That would give people a great degree of compatibility with not just CHIRP, but other programs as well. So that might be a decent thing to think about. All right, so we are going to go into just a few minutes of spreadsheet gymnastics. Honestly, this is probably kind of painful to watch, but if you've never gone through this exercise before, it's actually useful to see the mechanics of this. So I do want to do just a quick demo of this. That's all laid out step by step in the slide deck, but I'm going to attempt to do it as a demo here live. So here is this spreadsheet that I was talking about. This is what my Aries team puts out. And you can see it's got all the information that you would probably expect from a band plan or a code plug. It's got frequencies, receive and transmit. It's got channel names. It's got comments. This column is for FM narrowband. And so a few of these channels are narrow FM rather than standard 25 kilohertz FM. We do have this power column, which we may or may not use. After a certain point, we actually have a distance column for these repeaters, distance away from our primary area of concern. And CHIRP is not really going to have a place for this, but it's still good to have in this band plan that the team keeps track of. So anyway, this is not in the shape that CHIRP is going to want. The headers need to be certain names. They don't need to be in a particular order, but they do need to be certain names. And you'll see there's a couple of other transformations we need to make. The first step I'm going to do here is I'm actually going to go to CHIRP and save this CSV file. And I'm just going to generic CSV, that's fine. I just want these headers in the name and the order that CHIRP is going to expect. And I'm going to import that into my spreadsheet here. By the way, I'm using Google Spreadsheets here. Any spreadsheet program will support the kind of things that I'm showing you today. It's really a matter of personal preference. This is just what I have on hand. So this is what I'm going to show you. I'm going to opt to put this in as a new sheet. So it's going to come down here as one of these tabs at the bottom. And indeed, it does have all of these headings across the top that CHIRP is going to expect. And I'm going to copy and paste my team's code plug into here. One of the first things that I personally prefer to do is to take out all of the formatting. So you see here right now, these headings don't actually match up with what's in the columns. So I'm going to use liberal use of copy and paste and creating columns and deleting columns. This location here, this is referring to the channel number, and so that actually matches up right now. Right now this is done with formulas. I would really like those to be stuck in place. So one of the tricks that I use is to copy things that are formula based, and then I paste as a value, and that way, you know, now we are not dealing with formulas, we're dealing with concrete numbers that aren't going to change when we move stuff around. So that's one of the tricks I use. Next thing up, CHIRP is going to want a channel name. What we've got under here are the receive frequencies. So I'm going to create a new column on the left and cut this over. And where did my channel names go? Here they are. So I'm going to, oh, come on. I'm going to move these things over. So now location and name match up. Next thing that CHIRP wants is a frequency. But you might notice that we're getting into a problem here, because what my team's code plug gave me is receive frequency and transmit frequency. CHIRP uses the receive frequency and the offset. So now we've got to do just a little bit of juggling here. I'm going to put in a new column here, and I am going to move this header over, and I'm going to move the receive and transmit frequencies over here. So this column is good to go. This column, TX frequency, I'm going to have to get rid of, but before I get rid of it, I'm going to have to use it to do some math. So duplex, this, I didn't really understand this when I first saw it, so I went in the software and I took a look at what duplex, what possible values it can be. Turns out it's plus for a plus shift, minus for a minus shift, split or off. And those are the values that CHIRP is going to expect, or it could be blank. So let's move these headings over. First, I'm going to calculate this offset, because this is actually the easier of the two things. Offset should end up being, and this is where spreadsheet formulas come in handy, offset is going to be the transmit frequency minus the receive frequency. And yes, I do want that formula all the way down. Okay, so now I've got some -5s, I've got some minus 0.6s for VHF stuff, and hopefully those are all, you know, oh, here's a repeater pair that's only off by 2 megahertz instead of 5 megahertz on UHF. So that's kind of odd. This is, you know, an easy way to do some data quality checking on your data as you're going through this. But for now, really, what all I want to do is I want to fill in this duplex column. And again, this is going to take some spreadsheet formula work. If this offset number is greater than 0, then we want this column to be a plus. Instead, if this offset is less than 0. We want that to be a minus. If it's exactly equal, we just want it to be blank. So there's that formula all the way down. And this should actually take care of this duplex column. We've either got pluses or minuses or blanks. I don't expect that there are any splits or any, I mean, we might be able to use duplex off, but I think duplex blank works just as well from experience. Okay, so we've got this duplex column. It's the values we need now. But if I end up deleting values, if I end up changing values out of this column, because we need all of these to be positive numbers. So if I change this column to be positive numbers, all of a sudden our duplex values change. That's not what we want. So once again, rather than having these things be formulas, I'm going to copy them, paste them as values. Now they are concrete values instead of being calculated formulas. So they're not going to change anymore. Next, since all these offsets need to be positive, I'm going to throw an absolute value on these. And copy that formula all the way down. Okay. And now I can delete this entire TX frequency column completely because we no longer need it. Oh, look at that. These are still formulas. They're not values. I'm going to undo, copy, paste as value. Let's try that again. TX frequency, delete column. Okay, now we're in good shape. All right, and hopefully you've got the picture now that we're just moving left to right, one column by another, just trying to make this fit what CHIRP expects to see. Any questions on that so far?
So to not have to do this every time you update the spreadsheet, is there like a special character that means everything beyond year just ignore, so that you can do fields to the right where you do all of this calculations and then just have the fields with the data that you want to export over on the left?
That would be really useful. I don't think that exists today.
Well, it's open source. When are you going to make it happen?
As soon as I finish with all the other open source projects I'm working on. It's all just a matter of time. I mean, we're all getting paid the big bucks here, right? I'm not retired yet. That's the big problem here. As soon as I'm retired, then I will fix all of these problems for you. All right, let's continue with this tone column. Again, I don't know exactly what these values ought to be, so I'm going to go back to CHIRP and see what these should be. So possible values are blank, tone, TSQL, DTCS, and a few others that we're not going to need. All right, so these things that came out of the band plan as tone, we can keep those. Things that are none, we're going to have to just delete those and leave them blank. These TS1, TS2 things are more interesting. Anyone want to shout out what TS1, TS2 must be?
DMR, time slot 1 and 2.
DMR channels. And CHIRP does not handle DMR channels at all. If we try and give this to CHIRP, it's going to vomit and it's going to tell us to go back to the drawing board. So I'm going to turn on filtering here. Anything that is tone, is already in good shape. I'm going to ignore those. For now, I'm actually going to ignore the nones. We'll come back to those and turn them into blanks. But I'm going to filter out the ones that I think are okay. And I'm going to focus on these ones. These DMR channels. Since CHIRP is not going to handle them, I'm just going to get rid of those rows. Delete selected rows. Done, they're gone. As long as I'm here, these NAs, these are HF frequencies, and you might be interested to see what happens when we give these to CHIRP, so I will leave them in. But I'm going to delete the NAs so that it matches the blanks that CHIRP expects. We have one channel in this list that is DCS rather than CTCSS. This is going to be a little bit interesting. This was from the band plan that I got. This was just listed in the same, the DCS tone was listed in the same column as the CTCSS tones, which is perfectly fine as long as you're looking at this manually. But you see up here at the top, CHIRP is going to expect a receive tone frequency, a transmit tone frequency, I don't know why that's C, but whatever, and then a separate column for DTCS code. So we'll have to move that around again. But let's start with this DCS tone mode. CHIRP is actually going to expect DTCS, so we'll change that. Okay, and let's go back to the values, the rows that have none in this tone column. I'm going to select all those, and I'm going to delete none, because CHIRP is going to expect blank. And if I come back here, I've still got some nones. I only want to see things with none. Okay, so now everything in this column has a value of tone, blank, or DTCS. So CHIRP should be satisfied with all of those values now. All right, so moving on to the tone frequencies. Let me get another column in here. So really, I should only need to put these tone values in the transmit tone CHIRP column, but for whatever reason, I just tend to duplicate it between them. So this column is the same as that column, and copy and paste value. We've got to come back and find that one funny channel. Here it is. Insert one left. All right, so I'm going to move this DCS code heading and channel 75. Here it is. So this channel does not need a DCS code at all. Instead, we're going to put that in its own column. And let's see, what else do we have? Transmit power, actually there's no place to import transmit power into CHIRP. So actually I'm just going to delete those. Okay, this column, if you recall, this was whether the channel is narrow FM. And we've got a couple of values in here. We've got yes and on, off, and A. CHIRP is going to expect that in the mode column. And if we come back to CHIRP, we see that mode is kind of a smattering of things, but FM and NFM for narrow FM are the values that we care about in here. So to start off, I'm just going to fill all these with FM. Oh, and these were the distance values. Again, there's no place to put that in CHIRP, so I'm just going to overwrite those. Okay, so all these start out as FM, and now I'm going to sort by the off-on column that I got from my code plug. I'm going to ignore everything that said off, because that's already FM. And if it's either yes or on, I'm going to change that to NFM. There we go. All right. And the rest of these are NA. Some of these are, like this channel is LSB, so I'm going to change the mode on that. This one's LSB, but you know, for the most part, we are done with this column, so I'm going to delete that. We're getting towards the end, I promise. Okay. So the last column that has any meaning that came from my band plan is this comment. So I'm going to cut this column heading for comment and paste it in there. The rest of these columns, these are headings that came from CHIRP, but we don't really have any meaningful values to put in there. So I'm actually just going to delete all these headings. And we're really, really close, except there's one super annoying thing about CHIRP that I might fix sooner rather than later. Some of these columns, like the tone column and the duplex column, will accept blank as a valid value. The tone columns and the DCS columns will not accept blank as a valid value. You've got to put some default in here everywhere this is blank. So what I tend to do for DCS is 23, which is, I think, the first valid value there. I'm just going to copy that in everywhere that it's blank. And let me select everywhere that we have a blank tone. And I'm just going to put 88.5 as a default value for lack of anything better to put there. And copy that all the way through. That's interesting. We had... Oh, these are reserved channels. That's why they say they're tone, but they didn't have anything populated. I'm going to get rid of these reserved channels. Delete 2 rows. We've got a couple more that are reserved. Delete, delete. Those are not useful in code plugs. Okay. So I'm going to show everything again. And here we have it. I think we have a spreadsheet that matches what CHIRP is going to want. So I'm going to export this as a CSV file. Yes, CSV. And moment of truth, I'm going to try and import it in CHIRP. Yeah, this is the one I just made. Hallelujah, it worked. Okay. So this is CHIRP's import dialog. And what you can see here is this is the original location that came from the file. But if we want, we can actually move these to different locations when we import it. So this is useful if you're taking, you know, 2 or 3 different CSV files or, you know, other sources, and you're smashing them together. You don't want to overwrite things. You want to offset them so that, you know, the first CSV goes up here and the second one goes down here. So this is a useful way to control where these things are going to land. In my case, I really want these channel numbers to match up with what came off of the code plugs, so I'm going to keep those. But you know, this is an easy way to double check that everything looks the way you want it before you dump it into CHIRP. Notice here that it took these 6-meter and HF channels just fine. This is a generic CSV code plug. We're not talking about a particular radio yet. We don't know if it's going to be 2-meter only or 70 centimeter only, or if it's going to be an HF rig. So we can put whatever channels we want in here. We've also got a bunch of receive only channels that are not even ham channels. They're MERS, they're Blue Dot, they're FMRS, FRS, GMRS, NOAA channels. CHIRP at this stage doesn't care what the radio is capable of, because we haven't even told CHIRP what radio we're using. So I'm going to go ahead, don't worry about this, this is just because my monitor's weird. I am going to import this, and this code plug looks exactly the way I want. This is ready to go on each of my radios in turn. Any questions up through this point? That was a lot of information, and unfortunately sort of painful by necessity, but now we're getting to the good part. We're going to start loading this generic code plug, and we're going to start putting it on radios, which is probably the part you are here to see. Okay.
I'm dying to see how your Baofeng is going to do single sideband.
Yeah, it's so we will take a look at that. Okay, back to the slides for just a moment. The general process here is the first thing we need to do every single time is we need to read from the radio. That's the way it gets a baseline of what the radio memory looks like every single time. It doesn't have like a template that it uses for each model. And oops. Okay. And yes, we will start out with the lowly Baofeng. It's the lowest common denominator. Every single person, every single ham owns one of these things, and so it's, it's a common place for us to start. Here are the radios that I'll be demonstrating on. Like we said, DMR is out. Any tone is not supported. The three that we'll be taking a look at tonight are the Baofeng Yaesu FT3D and the Kenwood THD72. I enjoy all of these radios for different reasons, and tonight I want to make sure that I have all of the channels that I care about on all three of these radios. So let's start with the Baofeng. Love it or hate it, it's everywhere. Most of the time you're going to need some kind of programming cable for these, and in the slides I left a couple of examples of where you can get these things, but generally eBay or Amazon, you can find these things. They're not terribly expensive, but something to go between the computer and the radio, and usually it's just some sort of serial UART thing. So if you really wanted to, usually there's a way to build these things yourself. All right, so I have cleared out this Baofeng for the purposes of tonight's demo. This is basically factory fresh, other than I turned off the annoying beep and the Chinese voice, because I wasn't going to stand for that during the presentation. So let's first download from the radio. Here under port, if you're used to Linux, this looks really familiar. If you're on Windows, which is probably the majority of people, this will be a COM port. So again, that's going to be familiar. We're going to start out with Baofeng. And you can see how many manufacturers is ported there. This is a UV5R. And hit OK. We are downloading for the radio. It gives me some useful instructions here about what I need to do for this particular radio. It says I need the volume all the way up because this data transfer is happening at audio frequency. So volume all the way up. OK. And I got a red blinky light here because it's downloading. This one doesn't take all too long because it's a pretty small memory bank. Now, up here in the top, you notice there's a new tab, Baofeng UV5R. This tab is specific to a Baofeng. It will not accept HF channels. It comes with the couple of channels that were default programmed into the radio. And so what we're going to do is start at channel 1, and I'm going to try and copy and paste all these things in here. Uh-oh, I'm trying to copy 239 things. Baofeng only supports 127. I have to pick and choose which of these channels is going to go on here. And so for my purposes, I'm going to choose 1 through 73. Oh, real quick, I should note here, there's an option up here that says Show Empty. This will either show or hide. It will toggle between showing these channels that have nothing in them. And if you are in a situation where you're trying to get channel numbers to match up with everyone else, this is important. If I click Show Empty, and I start copying these channels, it's just going to increment these channels instead of keeping the channel numbers. And so I will not match up with everyone else. This ends at 38 when I had copied through 42. Show empty channels, and show empty channels here, which it is. So if you're trying to get channels numbers to match up, that's important. I'm going to copy 1 through 73, select number 1, paste it in. Yes, I want to overwrite. Okay. So now I've got 1 through 73, and there's appropriate skips where there should be. You might remember some of these skips were due to DMR channels and such. And I'm going to come down here. I would like to keep UHF and VHF packet channels. So I'm going to come down here and copy those down below here where there's nothing. You can see you can kind of slice and dice this thing to your heart's content. Copy, paste. And I won't say it's a perfect experience, like I'm going to cut this MERS channel and paste it, and seems like it just copied it instead of cutting it. But, you know, it's pretty good. It gets the job done. This is open source software, and I meant to say at the beginning, open source software tends to come with the trade-off that, you know, it's often a little rough around the edges. And this is one example of that.
Hey, watch it.
It's, you know, it's good enough. Like I said, I still prefer using this day to day for most stuff, even with warts and all. All right, so I've got the channels in the Baofeng tab set up the way I want. I can come over to here also to this settings tab, and these are the other things on the radio that you might like to set. So perhaps instead of showing frequencies in memory mode, I want to show channel names. So I'm going to set that setting. Now let's upload this back to the radio. Upload to radio. These things are actually locked in because I'm on a tab for a particular radio. The only thing I can change is the port, just in case I moved the plug, but I didn't, so I'm going to accept it. Again, it says your volume should be all the way at 100%. Okay. Now I get a blinky green light. And this takes just a little bit. Okay, it's transferred over, the Baofeng resets, and it went into memory mode. Right now, both the A channel and the B channel, or is it the other way around? Anyway, both channels are currently on channel 1. Let me swap over, and yep, you can see the channel number here. I've got the program that I expect. So, woohoo! We've got a programmed Baofeng. Any questions on that one before we move on to a more interesting radio? Did I lose my chroma key? Interesting. Actually, I'm going to skip the Yaesu for now because we're running a little bit low on time, and the Yaesu just takes forever to upload and download. But no questions on the Baofeng? All right, that is okay with me. So now we're going to do the same thing with this Kenwood. All right, I closed out the Baofeng tab, so now we're back to just the generic CSV code plug here. All right, again, I want to start with downloading from the radio. I want to choose Kenwood. They've got this detect feature, which doesn't work for this particular model, but seems like it would be pretty cool. For THD72, there's actually a couple of modes here that we can use. Clone mode is kind of what we are used to, what I just showed you with the Baofeng. You copy and paste an entire code plug at once. Live mode is kind of interesting. It will let you view the radio and change one value at a time, and it writes just that little piece. I wouldn't call it super useful, at least not with this Kenwood, because it's just too slow. You know, it takes minutes to load the entire thing from the radio into CHIRP, and then editing individual values is similarly slow. So I'm just going to show you the clone mode. Perhaps with other radio models, the live mode is actually more interesting, but with the Kenwood, it's not worth using. Whoops. I didn't hook it up yet. I need to turn it on. All right, once again, this is factory reset. This Kenwood is actually nice because it takes a standard mini USB cable here. It doesn't take a specific cable that you need to buy just for the radio. All right, so I'm going to plug in to the radio and plug into my computer. Okay, and let's again download. Normally when I'd hit this OK button, I would see instructions for the radio, but with the Kenwood, since it's so easy to upload and download, I don't get any instructions. It just starts doing it, which is super nice. Okay, so now we've got our tab up here at the top for the Kenwood. It has no channels in it so far. It's got, looks like it's got up to 1,000 channels, so I should just be able to copy and paste channel 1 through whatever. start here at channel 1. I want to select the same starting channel, again because I'm worried about these channel numbers matching. I started at channel 1 here. I'm going to choose channel 1 here and do my paste. Pasted memory 231 is not compatible with this radio because 6 meters doesn't work on this radio. Fine. Fine, 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 fine. So come down here to the 200s. This whole range is gone, which is okay because 230 through 237, those were all 6 meter HF channels. It's okay if they're not on the Kenwood. So it gracefully handled everything else. I've got all the channels I want. Come over here to settings, and you'll notice it's very light over here compared to the Baofeng. It's very, very light compared to what we would see on the Yaesu. You know, depending on the individual developer who integrated this radio and wrote the driver for it, they might not have cared about creating every little setting in here. So this is where you would have to go back to the manufacturer CPS or to RT Systems if you really, really wanted to expose these different values. But I'll go ahead and change this power on message just for fun. Once again, I'm going to upload to radio. These things are locked down. The only thing I can change is the port possibly, but I don't need to. So, okay, I'm going to start uploading this. And that was really, really fast. In VFO mode, it still shows nothing. But if I switch over to memory, there's my channels. And I've got everything I would expect to have here. Any questions on the Kenwood? I'm afraid we're running out of time, so we won't be able to look at the Yaesu, but it is very similar to both of these radios. It's more similar to the Baofeng in that, you know, it's a download, modify, upload kind of thing. And it requires some special instructions, and CHIRP will tell you exactly what you need to do with the individual radio as you're doing it. We're coming down to time. Any last questions here?
Isn't it also true that with CHIRP you can set at least some basic radio functions other than just channels?
Yeah, that's true. So, like with the Kenwood, you can change some of these values through the settings tab here. The Yaesu, you can actually, I don't know why I'm showing this because I can't actually show you, unless maybe I have it in the slides. Let me see if I captured this in the slides. Yeah, you see here in the Yaesu, you can actually set all the APRS stuff. You can set a lot of the radio functions besides the channels in the Yaesu here. So depending on the radio driver, you may or may not have these options.
Does the Yaesu use a cable?
Yes, it does. And for this particular model, I left a link in the slides to get it. This particular Yaesu uses kind of a weird one. Let me see if I can pull that up here. Where did it go? Yeah, okay. So let me get that back on camera here, and we are just about out of time. On the right, you see a standard USB mini, and on the left is the Yaesu cable, which is just different enough that I don't think it works with a standard USB mini. And so this particular cable I got off of eBay. And it was, I think they are more expensive these days because of the chip shortages, but you know, they are usually reasonable prices. Anything else before we wrap up?
How dangerous is this? If I accidentally try to upload a Baofeng code plug to a Yaesu radio, am I going to totally hose my Yaesu?
So for starters, I've never actually tried that, but there are some safeguards to keep you from shooting yourself in the foot that way. For one thing, I think that's one of the reasons that you are forced to download before you upload. It's kind of a safety measure to see that you have the right radio plugged in for the code plug that you're attempting to use. I have heard some anecdotal horror stories about people being able to brick their radios. I think that is extremely rare. I think that's mostly if you're a developer who's mucking around with trying to make a new driver for these things. I don't think it's a common thing, but you know, it's worth doing your due diligence and double checking that you're doing what you expect you're doing. That's my 2 cents.
Any other questions? There's something in the chat. Oh, no, never mind.
All right. Well, thank you all for your time.
Well, and thank you, Chris. I really appreciate you being our first guinea pig out of the gate, just like last year. So appreciate your time putting all of this together and for a very, very interesting presentation. Very much appreciated.
My pleasure.
Nice background, Chris. I happen to know exactly where you were standing when you took that picture.
Yes, I believe you do, and I believe Willem probably does, and anyone who
Do you
worked
see
the
me
Dirty
waving?
30 probably recognizes that.
Don't you see me standing right there and waving?
That's his truck.
This is from the top of City Lights Ridge, looking down at the Dirty 30 Aid 1, Aid 4 station.
It's up in Jim Casey Zero RPS's neighborhood.
In the mountains.
Golden Gate Canyon State Park.
Yeah, that was fun. I'm glad we got to do that this year.
All right, anything else? I don't hear anybody jumping up and down.
Thanks, everybody.
Thanks, Chris. I have some tips and tricks for you to get better resolution out of your outbound video too.
That would be wonderful.
I will teach you how to do that.
Yeah, this was a lot trying to juggle OBS this time, but I would be happy to learn more.
Call me and I'll help you out.
Sounds good.
All right, if there's nothing else, we'll end it here. Thanks everybody for showing up. It's much appreciated. Remember Rocky Mountain Ham University coming up. I closed that screen. What's the date, Willem?
November 13th.
November 13th at Cherry Creek Public Schools starting at 8:30 in the morning. And you'll get to put up with Willem and I being your instructors. It's more of a hands-on, so bring a computer and your thinking cap. Thanks again. Have a good night, everybody.
Good night.